Greetings everyone. Today inshallah we will start our new lecture. I will talk today about determinants, which is really very simple topic, and I will go to eigenvalues and eigenvectors together inshallah. Of course, all the course notes and everything you will find it on Moodle. Also the recorded lectures you will find them on the YouTube. I would like to talk first about determinants and their application. Determinants is very simple topic to talk about. Determinants is usually just a number representing the value of a matrix. And it's easily evaluated if you look to the coming examples. Of course, you know some about determinants. So if I have a determinant of a matrix 2 by 2, it's very simple to evaluate. How to evaluate it as 5 times 2 minus 1 times r. Once more, 5 times 2 minus 1 times r. Of course, all of you understand this is the principal diagonal and that's the secondary diagonal. Once more, that's the principal diagonal and that's the secondary diagonal. So all I have to do, if I want to evaluate a determinant of a matrix 2 by 2, multiply the elements of the principal diagonal minus the elements of the secondary diagonal. We already know about this. Okay, for a 3 by 3, we have two main methods. For a 3 by 3 determinants, we have two main methods. If I have a matrix 1 by 1, what's a matrix 1 by 1? It's one row, one column. So it's going to be a number. The determinant will be that number. So if I give you a matrix, for example, the matrix A is 5. So the determinant of A is equal to 5. Very, very simple. If I give you a matrix 2 by 2, let's say A 2 by 2, which means 2 rows, 2 columns, as you know. So if it is 1, 2, 3, and 4, it's very, very simple. All you have to do is multiply the elements of the principal diagonal, so it's going to be 4. Don't forget minus. Minus 2 times 3, which is going to be 6. The result is going to be negative 2. In case we are talking about a 3 by 3 matrices, the determinant will be a little bit difficult. But mainly you have two rules to evaluate a value of a 3 by 3 determinant. The first of them is called Sarah's. I like to give you Sarah's rule. One of the very successful rules to evaluate a 3 by 3 determinant. So if you look to this determinant, it's simply 10, 7, 0, then you will have negative 3, 4, and 6, then the last row will be 5, 6, and 5. If I want to evaluate the value of the matrix A, which is 3 by 3, I will go like this. First, identify the elements of the principal diagonal. What are the elements of the principal diagonal? 10 times 4 times 5. So I will start. Hamad 10 times 4 times 5, then plus. Remark that the principal diagonal, okay, divide this determinant into an upper triangle and the lower triangle. Can you see the triangle? Okay, look to the principal diagonal. You will have an upper triangle and a lower triangle. Am I right? So, every triangle contains base and the vertex, am I right? So I will multiply the elements of the principal diagonal, which are 10 times 4 times 5. Then I will multiply the elements of the base of the upper triangle, which are 7 times 6 times the vertex of the lower diagonal, which is 5. Hala, can you do it? Okay, once more. I will multiply 10 times 4 times 5. Then diagonally, go for the base of the upper triangle, which is 7 times 5. Okay? Do the same for the lower triangle. So I will go for negative 3, 6, then the vertex of the upper triangle, which is 0. So I will go plus, I will take negative 3 times 6 times 0. Then I will repeat the same process. but with the secondary diagonal. Okay? Similarly like for the secondary diagonal. That's the secondary diagonal. Here's the secondary diagonal. So start minus 0 times 4 times 5. 0 times 4 times 5. Then minus. Exactly the same. The base of the upper or the lower triangle times the vertex of the upper one. So start, I can go for 7 times negative 3, 7 times negative 3, then 5. Do it once more, minus 6 times 6 times 7. 6 times 6 times 10. You will have the value of your determinant. This is called Sar's rule. I will do it once more. It's really very simple. All I have to do is to go through the elements of the principal diagonal, which are, do it by your eyes, 10 times 4 times 5. Then plus the elements of the upper base, which is 7 times 6, times the lower vertex, which is 5. Vice versa. Then plus negative 3 times 6 times 0. That's for the first 3 units. Then I will do 3 units also, but using negative signs. Minus, I will go 0 times 4 times 5. Minus 6 times 6 times 10. Minus 7 times negative 3 times 5. I will be able to evaluate the value of this determinant. So, here you go. Here are the numbers once more. 10 times 4 times 5. That's for the first part. Then 7 times 6 times 5. Here we go. Then negative 3 times 6 times 0. That's it. Of course, if I'm multiplying down the road and I have 0, so this term will be removed. Am I right? Okay, I will read it once more. Minus 0 times 4 times 5. It's done. Minus 6 times 6 times 10, 360. Minus 7 times 3, negative 3 times 5. Please be careful about the sign conversion. Okay, so negative times negative is going to be positive and so on. The value of the determinant is 155. Actually, there is another rule. The other rule is called Laplace method. Do I have to know the 2 rules? Yes. Because Sar's rule is very successful with the 3 by 3 matrices. Okay? But it's not going to be applicable or successful as it is with dimensions greater than 3 by 3. So now, for the 2 by 2, it's very simple. Multiplying the elements of the principal diagonal minus the secondary diagonal. For a 3 by 3, I will do Sar's rule. Okay? I will show you now the Laplace method, and it's really very important. The Laplace method, it's simple. It will depend on eliminating some rows and some columns, as you will see. First, before going to Laplace method, there is what is called the sign rule, which is combined to determinants in general. Mr. Ahmed, it will start with a positive. So if I'm talking about 2 by 2, this is going to be positive. Then I will go negative. Then I will go zigzag. So positive, negative, positive, negative. Do you read me? Okay, once more, start. I will go for the 3 by 3. So I will start positive, negative, positive, then negative, positive, negative, then positive, negative, positive. This is what's called the sign rule. It is the sign rule. I will use it in some situations, in getting an inverse, in using Laplace and so on. There is another way to evaluate these signs, but this is the simplest. And also I will make you understand how we evaluate it relative to the other methods. Okay, here we go. This is the exact determinant that we were evaluating using Sar's. First, you have to choose any row or any column that you like. I will go with the first row since it is our first meeting with this method. So I will go with the first row. What is the sign rule, Mr. Hazan? The sign rule for the first row. What's the sign rule? Positive, negative, positive. So I will start positive. Take 10, eliminate the row and the column. You will have what is called a cofactor, which has a dimension less than this dimension by 1. Once more, I will take 10, eliminate the row and the column. Give me the sub-matrix numbers. So it's going to be 4, 6, 6, and 5. Here we go. So first of all, the sign, which is positive. I will take 10, which is in the corner. Eliminate the row and the column. What's the remaining numbers? 4, 6, 6, and 5. Okay? I will repeat this sequence, Mr. Muhammad Tariq. I will go for 7. The sign of the 7 is, so I will go negative over 7. That's the 7. Eliminate the row and the column. Eliminate the row and the column. Write the remaining numbers, which is going to be negative 3, 6, 5, and 5. Here we go. Once more, I will go for the last number. The sign is positive. Then take the 0. Eliminate its row and column. What's the remaining? Negative 3, 4, 5, and 6. Negative 3, 4, 5, and 6. Now I can evaluate each one of these 2 by 2 matrices, or 2 by 2 determinants, I'm sorry, very easily, which is going to be 4 times 5, 20, minus 36. Times 10. For the second one, negative 3 times 5 is going to be negative 15. Minus 6 times 5, which is going to be negative 30. So a total of negative 45 times negative 7. The last one I'm not going to evaluate because it is 0 times something. Am I right? So you will be able to evaluate this thing. What's the simplest method? This method or that method? This one? Okay. This one is really very simple, especially for a 3 by 3. I will tell you why. This method is very good with determinants greater than 3 by 3. If you remark, this is a 3 by 3 determinant. Am I right? Okay. You expand it into 3 determinants, 2 by 2. So if I have a determinant 4 by 4 ya Tariq, it means I will have to expand it into 4 determinants. Each one of them will be 3 by 3. Okay? So 3 by 3 for each one of them. This is going to be simpler for you to evaluate. So if I have 4 by 4, 4 by 4, 4 rows, 4 columns. If I'm using the plus method, there is no other way. Or that's the best way to go with. I have 4 by 4, so I will choose any row, any column. Mr. Hazim, if you have 4 by 4, you will have to eliminate row and column. So if you eliminate row and column from a 4 by 4, you will end up having 3 by 3. So if you insist on using this method also, so the 4 by 4 determinant will be 4 3 by 3, and every 3 by 3 you will expand it 3 2 by 2. So it's gonna hold. It's gonna be 12 2 by 2 determinants. This is why you will have to understand very well how to play with Sar's rule and how to use Laplace rule. معايا مسحاب؟ اتفضل. Yes, you can use it. Okay. And you can use it. But if you have a 4 by 4, you have to expand it first. It's gonna be 4 3 by 3. 4 by 4? It's okay, but it's gonna be very long. Okay, you are missing. Okay. I will show it to you quickly. Because it's rare to have a 4 by 4 system, but just in case if it happens, it's very simple. Let's take any numbers. Help me out with any numbers. So let's start negative 1, 0, 2, and 3, 4, 0, 6, and 7, 2, negative 1, 1, 3, 1, 2, 0, 0. Let's say. That's a 4 by 4 determinants. Okay. There is no other way. You will have to choose Laplace method. So choose wisely. Any row or any column. But remember the sign. The best choice, of course, if I went with the first row, how the sign is going to be? Positive, negative, positive, then negative. Don't forget that. start with the first row first to show you the eigen. Okay? I will start with negative 1. So if this is B, the determinant of B is going to equal to negative 1, which is the element negative 1. The sign is positive, so it will remain as it is. I will eliminate the row and the column. Can you write me the 3 by 3 column, the 3 by 3 determinant? Huh? 0, 6, 7, and negative 1, 1, and 3, and 2, and double 0. Then I will go to the second element, which is negative for the sign rule. The element is going to be 0. Eliminate the row and the column. Eliminate the row and the column. What's the remaining numbers? 4, 2, and 1 for the first column. Then 6, 1, and 0. Then 7, 3, and 0. Then I will go for the next number. The next number is going to be positive as a sign. 2, then eliminate the row and column. Eliminating the row and the column will leave you with 4, 0, 2, negative 1, 1, and 2. And the last column is going to be 7, 3, and 0. Then negative for the sign rule. Then the number after, which is going to be 3. Then eliminate the row and column. Eliminate the row and the column. So the remaining will be 4, 0, and 6. 2, negative 1, and 1. 1, 2, and 0. Are you with me? So once more, Mr. Ahmed, for a 4 by 4 determinant, I'm ending up having 4 determinants, each one of them is 3 by 3. Doesn't make any sense. To break also each one of them to be 3, 2 by 2. Okay? It's going to be difficult to you. It's going to be a huge number of determinants. But now it is better for you to use the Saras rule. Let's do the Saras rule. So I'm combining with it. Let's do Saras rule together. Me and you. I will start 0 times 1 times 0, which is 0 plus 6 times 3 times 2, which is 36. Here we go. That's 36. Okay. 3, 6 times 3 times 2. Then negative 1 times 0 times 7, which is plus. It's equal to 0. I'm not going to write it. Then I will go minus 7 times 1 times 2, which is simply 14 minus 3 times 0 times 0, 0. 6 times negative 1 times 0, which is 0. I've evaluated this determinant very quickly. But don't forget that the sign in front of all of these numbers is negative 1. I will repeat the sequence once more. With the second, with the third, and with the first. Do you read me? So if I have a 4 by 4, I will have 4 3 by 3. Am I right? Can you imagine if you have a 5 by 5 determinant? How many 3 by 3 determinants are you going to face? The 5 by 5, it's going to be expanded into 5 4 by 4. And each one of the 4 by 4, it will be breaking down to 4 3 by 3. So actually, for evaluating the 5 by 5, you will end up evaluating 20 determinants. Each one of them is dimension 3 by 3. You read me? If you use the plus for a 3 by 3, it's going to be 60 determinants 2 by 2. This is one of the major problems with dealing with determinants. But we need them. شباب فاهمين انا بقول ايه؟ It's really very important. السؤال انا هيجي لي 5 by 5? No. But now I know what's the problem with the big dimension using the methods depend on determinants, the evaluation of determinants. Am I right? Okay. Enough with the evaluation of determinants. Now I will go to some of the properties of matrices and the relation between them and determinants. It can go with any row or any row, but you have to obey the sign rule. So I can expand Your question is very nice. It's very good. I can choose any row or any column. So if I was going to evaluate the value of this determinant, I would prefer not to work with the first one, but I would prefer to work with the last row. Why? Because it contains more zeros, okay, than the first row, so it will help you out. Also, I can use the second column, but just remember to obey the sign rule. Do you remember the sign rule for the second column? Positive, negative, stop. Negative, positive, negative, positive. Are you with me? Okay. There is no successive positives following each other, and there is no successive negative signs. It's usually positive, negative, positive, negative. There is another check. Do you know that this element, what's the position of this element? This is first row, second column, am I right? Sorry? First row, second column, this element. The sign is going to be negative. If I go for this number, what's the position of this number? Third row, third column. Add these numbers on each other. If it is even, the sign is going to be positive. If the sum of these two numbers is odd, the sign is going to be negative. Hala. Each number of these numbers has a relative number to its position in the determinant of the matrix. So this number is simply 1, 1. First row, first column. This number is simply 1, 2, 3. So it's a third row. 1, 2, 3. So it's a third column. This is the position of this number. If you add them together, if the result is even, the sign will be positive. Okay? If you add them and the result is odd, then the sign will be negative, according to the sign. So now for the sign rule, I'm talking about the sign rule, which is positive, negative, positive, and so on. I can do it, positive, negative, and so on, zigzag. Or I can just remark the dimension of this or the position of this number. If you add I and j and the result is even, then the sign will be positive. If you add I and j together, the number of the row and the column together, and the result is odd number, like 1, 3, 5, 7, and so on, the sign will be even. Yes, for each even number, it's going to be positive. For each odd number, it's going to be negative. That's what the sign. Okay? Okay, very good. Now, I will talk about the transpose. What's the transpose? Replacing rows into columns or columns into rows. They found that the transpose of a matrix is not going to affect the result of the determinant. So if you have a matrix and you need to evaluate its determinant, if you bring its transpose, the value of the determinant is not going to change. Look, Ms. Hala, if I want to get the transpose of this matrix, what I have to do, instead of having the first row, it's going to be the first column. So just state the first column. It's going to be 10, 7, and 0. For the second, I will make it like this. So it's going to be negative 3, 4, and 6. Here we go. For the last row, okay, I will rotate it 90 degrees. That's the transpose. So it's going to be 5, 6, and 5. The transpose is to make each row as a column. Okay, that's called the transpose. It's not going to affect the value of the determinant. Those are important propositions. The questions usually in the exams target the propositions. Okay? So now I know that the determinant of a matrix or the transpose is not going to affect the value of the determinant. Also, this is very, very important. If you have a complete row or a complete column with zeros, so if I have this row or any column is equal to 0, all the elements are zeros, the value of the determinant is going to be 0. Don't evaluate. Also, if you have two rows or two columns equal to each other, then the value of the determinant is gonna be 0. Those are very, very important types. So if you have 2 equal columns or 2 equal rows, the value is gonna be 0. To determinant, in any determinant, it will satisfy these conditions. Okay, if the determinant of a triangular matrix, do you remember what is the triangular matrix? Triangular matrix, it's a square matrix, it's a question form, mainly. A triangular matrix with all the elements exist in the upper triangle or the lower triangle. In this case, the determinant is going to be very simple. The determinant is going to be the multiplication of the elements on the principal triangle. For example, if I have 4, 5, and 6, 0, 1, and 2, 0, 0, 3, that's an upper triangular matrix. See, the numbers are in the upper triangle. So if you want to evaluate the value of the determinant, it's going to be very, very simple. What's the value? It's going to be 4 times 1 times 3. That's it. Okay? So that's a very nice step. A matrix A is invertible if and only if the determinant doesn't equal to 0. And we already know that's what's called non-singular matrices. So what's a non-singular matrix? A matrix with a non-zero value of a determinant. And the value of the determinant, if it is not equal to 0, this matrix, you can get its inverse. So it's really very important remark. Not all the square matrices are invertible. Just only the ones which are non-singular. What's the non-singular matrix? The matrix with its determinant doesn't equal to 0. Okay? Also, for any n by n matrices, A and B, remark, remark, remark. The determinant of A times B is equal to the determinant of A times the determinant of B. So if I have two matrices multiplied each other, the determinant of both, the multiplication of both of them is exactly like getting the determinant of the first matrix times the determinant of the second matrix. Once more, those are really very important remarks. Number 5, the determinant of the inverse of a matrix, A minus 1, is equal to 1 of the determinant of A. So if I have a matrix like this, and let's say that's this matrix is called A. If I want to get the determinant of A minus 1, it's very simple. I don't have to get the inverse first. All I have to do is to evaluate the determinant of this matrix, which is going to be 12. 4 times 1 times 3, am I right? So the determinant of A minus 1 is going to be 1 over 12. This is really a very also good tip. So you have these steps, which is very important. Also, determinant of A transpose equal to the determinant of A. We already know that from the previous slide. The propositions are really important. You have to keep them in mind and always remind them. Okay, now I will go to a very nice method to solve a system of equations, Mr. Ahmed. This method depends on determinants. It's Cramer method and one of the classical methods. Remark, the Gabriel-Cramer method was done at the 17th century, at the beginning of the 17th century. Can you imagine how it is old, okay? I want to solve any of these systems. Now you are an expert in solving systems of equations, am I right? You have been using solving a system of equations for a decade now. In matrices and also in vectors, am I right? To check either if they are linearly independent, linear combination, and so on. Now, if I want to evaluate or to solve a system of equation using Cramer method, it's really very simple. I want you to remark how I'm going to be able to solve this system really very quickly and efficiently. The first step is to write the system as matrices. So I'm going to write the first matrix, which is done 3, 1, 1, and 2. That's the A matrix. Times x1 times x2, and the result is 5 and 4. Are you with me? And once more, I'm looking to the first row, 3x1 plus x2 equal 5. The second row, which is x1 plus 2x2 equal to 4. I'm going to put this system of equations into matrix form. So it's gonna be 3, 1, 5, 1, 2, 4. Already you know about this, okay? Look how it is nice, Mr. Hazan, to evaluate using grammar method. It's really simple. So I will go like this. X1 is gonna equal to. I will evaluate the value of the main determinant. What's the value of the main determinant, Ahmed? It's gonna be 3, 1, 1, and 2. Then I will write a determinant relative to the first value, which is log to this determinant. I will replace the first column, which is the coefficient of x1, replacing them by 5 and 2. That's the result matrix. And the remaining of the determinant is going to stay the same. So it's going to be 1 and 2. Now I will be able to evaluate the value of x1. Mr. Hazan, can you do the second element? I'm seeking the value of x2. That's x2. So all I have is to divide by the value of the determinant of the coefficient matrix, which is 3, 1, 1, and 2. Then the determinant on the denominator is going to be really, very simple. I will replace the coefficients of x2 by the result. So it's going to be simply 5 and 4. But the first column will remain the same, which is 3 and 1. Now I can evaluate the values of x1 and x2. See how simple it is. So it's going to be 5 times 2, which is 10 minus 4, divided by 3 times 2, which is 6 minus 1. And so it's going to be a 6 over 5. That's the solution of x1. I will do the solution of x2. Let's do it together. 3 times 4, 12 minus 5 divided by 3 times 2, it's a 6 minus 1. So you will end up having 7 over 5. Can you see how it is simple? This is how to evaluate or to solve a system of equations 2 by 2. It's very simple. So, remark, please close the light. Turn off the light. For a 2 by 2 matrix, for a 2 by 2 system of equations, I've ended up having how many determinants? 3. The determinant of the coefficient matrix, so just in a sec, I will put it to you in a system of equations. Here we go. That's the determinant of the coefficient matrix, which is 3, 1, 1, and 2. 3, 1, 1, and 2. Then I will get the determinant of the first column, or the first variable, which is going to be 5, 4, 1, and 2. 5, 4, 1, and 2. I will get the determinant of the coefficient of the x2, which is 3, 1. I will replace those numbers by 5 and 4, as you can see. The result is really very simple. x1 is going to be delta 1 over delta 2. So writing the coefficient matrix at the denominator, and write on the denominator just only the value with changing the column. You will have your results in front of you. Very simple. Of course, compared to the elimination method or Gauss-Jordan or whatever. The process will get harder. Once you go, but before we go forward, remember those were 2 equations in 2 unknowns. Am I right? You ended up evaluating how many determinants? 3? 2 by 2. Am I right? So the number of the determinants exceeds the number of equations by 1. So if I'm solving 3 by 3, please go to this system, the 3 by 3 system. I will have to evaluate how many determinants? 4 determinants. I will have to evaluate 4 determinants. The coefficient and the determinant for each variable. Once you are trying to solve using a common rule, you have to be aware that they will have to be well arranged. So the first equation, the coefficients are 10, negative 7, and 0. For the second row, it will start with negative 3, then positive 2, Mr. Hazan, then 6. And for the last row, it's going to be 5, minus 1, and 5. Are you with me?
هي الصورة واضحة ولا هيزي؟ ولا أنا عشان قريب من ها؟ واضحة صح؟
طيب, okay, perfect. I will go now for each one of them. Now I'm going for the first variable. The first variable, I will take the coefficients, which is 10, negative 7, and 0. 10, negative 7, and 0. The second row, which is going to be negative 3, positive 2, 6, negative 3, 2, and 6. The last one, which is going to be 5, negative 1, and 5. 5, negative 1, and 5. Okay? شباب انتوا معايا؟ خلي بالك احنا لسه مشوارنا طويل قوي. ماشي؟ احنا لسه قدامنا كتير. دي الماتريكس اللي ده الديترميننت للدينومينيتور. معايا يا احمد؟ I will get the determinant on the denominator, which is very simple. I will replace the first column by the result, which are 7, 4, and 6. Here we go, 7, 4, and 6. I will evaluate this determinant and then divide it on this one. This is for the first element. How to write the second element? The denominator will be the same. The denominator is going to be the same. But I'm going to replace the elements of the second column. So I will go for the second column, replacing those numbers by the result, which are 7, 4, and 6. Evaluate the denominator, and get the value. If I'm getting x3, I will do exactly the same. The determinant is the coefficient matrix. معايا safe صح؟ Safe. I will replace 0, 6, and 5 by 7, 4, and 6. Can you see it? Then evaluate it. How to evaluate? Use any method. You have how many methods? 2 methods. Either Sal's rule, which is simple. How to evaluate using Sal's rule? 10 times 2 times 6 plus negative 7 times 4 times 5 plus negative 3 times negative 1 times 7 minus, go for 7 times 2 times 5 minus 4 times negative 1 times 7 minus negative 3, negative 7 times negative 3 times 6. And then divide them together. Hazard, can you tell me what is the problem with grammar? What's the problems with grammar method? First of all, if the dimension or the number of equation exceeds 4 equations, it's going to be a disaster. Because for a 4x4 system, you will have to evaluate how many determinants? 5. And each one of them is going to be 4x4. So each evaluation of each determinant is going to be 4, 3x3. So it's horrible. The situation is going to be very, very difficult. And that's the major problem with using grammar. That it depends on the evaluation.